So when you report a quantitative measurement, there usually consists of two parts. One is a number, and the second part is a unit. So for example, if you measure 1 cup of sugar for baking, right? So without the cup, we don't know what that number means. 1 sugar, that doesn't make sense, right? So a number without unit is meaningless. So the number, it reflects the precision of the instrument or piece of glassware used to make that measurement. So for example, you can measure out 1 cup of sugar, or if you use a different type of measurement, it can be 1.00 cup of sugar. And that tells you that 1.00 is more accurate than 1 cup, right? So your number should reflect how precise, how accurate your measurement is. And in terms of units, there are two types of unit system. One is international system of units. So in science, international system units is commonly used for measurements. But we know that in the United States, we use the English system, right? So for example, when you look at the international system units, M means meters, right? So it tells you it's 5.9 meters and 2.7 kilograms. Kilogram means kg means kilograms. So this is another measurement of in the international system of units. So there are, based on what we're measuring, different units are used in the standard units of measurement. So for length, the SI unit is meter, and the symbol is M. For mass, the unit is kilograms, and the symbol is kg. For time, it's second, and the symbol is S. And for temperature, the unit is Kelvin, and the symbol is uppercase K. So we also will introduce a definition of mole later on in the semester. So mole indicate the amount of the substance, which is represented as mole, MOL. And for electrical current, we use the ampere, which is A. So those are the typical base units for different type of measurement in the SI units. And we'll talk about derived units, but that's based on the basic units. So derived units, they are units formed from other units. So for example, we know that meter indicate it's a measurement for length, right? So but volume is a measurement of space. Where did we get volume? Volume is equal to width times height times length, right? So when you times 3 together, and so the units of volume is usually cubic meter, cubic centimeter, cubic millimeter, and it can also be derived to milliliter or liter. So volume is derived from the measurement of length. So volume is considered a derived unit. So now let's have a look at temperature. So in daily life, when we measure temperature, we use Fahrenheit, right? So some countries we use Celsius. There is a conversion factor between Celsius and Fahrenheit. So based on the previous discussion, we've learned that the base unit for temperature in the International Standard Unit is Kelvin. So for example, water freezes at 0 Celsius, and this is 273 Kelvin, and which is also 32 Fahrenheit. And water boils at 100 Celsius, which is 373 Kelvin and 212 Fahrenheit. So there is a mathematical relationship between those three units. Celsius is equal to Fahrenheit minus 32 divided by 1.8. And then we can calculate Kelvin based on Celsius. Kelvin is equal to Celsius plus 273.15. So in chemistry, we commonly use Kelvin or Celsius. We rarely use Fahrenheit. If you're given Fahrenheit, you should be able to convert Fahrenheit to Celsius and then to Kelvin as needed. So for example, liquid nitrogen boils at 77 Kelvin. What is this temperature in Celsius? Okay, so now first we'll write the relationship between Kelvin and Celsius. Kelvin is equal to Celsius plus 273.15, and then you can plug in the Kelvin and calculate Celsius as negative 196 Celsius. So liquid nitrogen is considered cryogenic, which means it's a very, very low boiling point. So another example, let's say that your younger brother has a temperature of 40 Celsius. So what does that mean if it's in Fahrenheit? And we can convert Celsius to Fahrenheit using this equation. And then the Fahrenheit is calculated to be 104.0 Celsius. And this tells you that he might have a fever, right? So based on the relationship between Celsius and Fahrenheit and Kelvin, you should be able to convert one to another. So now we've introduced the base units in the metric system. So sometimes there are to shorten the way we can write numbers. We can also use prefixes in conjunction with the base unit to indicate, to basically shorten the way we write numbers. So for example, kilo, which the prefix is K, it means 10 to a factor of 3, that's 1,000. So 1 kilograms is actually 1,000 grams. So instead of writing 1,000, we can just use the prefix K to indicate it's 1 kilograms or 1,000 grams. So they mean exactly the same thing. By using prefixes, we can shorten the way we write numbers and it's easier to understand. Okay, so another example, a micrometer. Okay, so micrometer, which is 10 to the factor of -6. So instead of 1 micrometer is 0.000001 meter, instead of writing 0.00001 meter or 1 times 10 to -6 meter, we can also use 1 micrometer to show the size of the length, right? So another example would be tera or giga. So your cell phone usually nowadays it has about at least 256 gigabyte, right? So gig, it stands for gig, which is 10 to the factor of 9s. So instead of write 10 to the 9th bytes, and we can just show in gigabytes. And then there's also terabytes. So you can find this prefix multipliers in your textbook. So use this as a reference to find the conversion factors between one unit to another. There are also some units and in that shows the conversion between SI units as well as English units. For example, the converting between kilograms and miles, kilograms to pound, kilometer to miles, kilograms to pounds, meters to inches, and meters to yards, foot to centimeters, inches to centimeters, pounds to grams, ounce to grams, and gallons to liters, liters to quarts, all liters to milliliters, and cubic centimeters. So those are the important conversion factors we'll be using as a reference to when we learn about dimensional analysis and conversion factors.